Okay, so today we're going to be talking about the mean value theorem. Okay, so this is a traditional kind of start off with the mean value theorem. So you've got two stationary police cars equipped with radar. They are 5 miles apart on a highway. As a truck passes the first police car, its speed is clocked at 55 miles an hour. 4 minutes later, when the truck passes the second police car, its speed is clocked at 50 miles per hour. They pull over the truck and ticket him for speeding. Prove that the truck was speeding during that time. So basically, what we're seeing here is it's basically about velocity, okay? How fast this truck is going. So in 4 minutes, it traveled this 5 miles, but when the police officers tagged the truck, it was below the speed limit, which was 55 miles an hour. But they ticketed him for speeding. Well, how did they know that he was speeding? Well, it's about the law of averages, okay? So we'll agree that basically the position at 0, okay, at time 0, that's when it passes the first police officer, okay? So when he clocks him at time equals 0, his position is 0, right? Well, later, 5 miles away, okay, at time 4 minutes, right, which is 4 minutes out of 60 minutes, it's at 5 miles, okay? Because we're talking about miles per hour. So those 4 minutes, converting it to hours, it's 4 over 60. So it's average velocity. So if we're trying to find velocity, the average is, of course, d2 minus d1 over t2 minus t1. And our second distance is 5 miles minus our initial distance, which is 0. And then our time, which is 1 over 15 minus our initial time of 0. That gives me 5 over 1 over 15, taking 5, multiplying by the reciprocal, which is 15, which means the average velocity of the truck between that time was 75 miles an hour. So even though he was going the speed limit where the first cop was, and he was going the speed limit where the second cop was, altogether, his average velocity was 75 miles an hour, which means not only was he speeding, but he was going probably well over 75 miles an hour at some point in that time. And this is basically like the law of averages. If you know that the average velocity was 75 miles an hour, there had to have been a time where that truck was going at least 75 miles an hour to average to that. And that's what the mean value theorem is about. Okay? The mean value theorem says if you have this function and it's continuous over a closed interval from A to B, closed interval, and it's differentiable, which means it's smooth and it's continuous on the open interval A to B, then there exists at least one point in there, point C, that's between A and B, that this f prime, the instantaneous rate of change, is equal to the average rate of change. So this is the instantaneous rate of change has to be equal to the average somewhere. So there is at least one point where the instantaneous is equal to the average. And it's basically shown right here. If we're talking about slopes here, if this is your first point here and this point here is your second point, this slope of the secant line, there is some point in between there that average slope is equal to the tangent slope or the instantaneous slope at one point. And that's basically the mean value theorem. It's an existence theorem. It says, well, hey, if the average is there, there's got to be some place along that the instantaneous is there, because you can't get from here to here if it's continuous and it's smooth. You have to go through all of these slopes in between. So if you know what the slope is here and here, it's got to go through all of them. Okay, basically that's what the mean value theorem says. So what does that mean? Well, we just saw it using real world averages, but that also means, for instance, if I want to find out, hey, is there a place in this function, this cubic function, where the average slope is equal to the instantaneous slope, or the slope at a point, okay, or the derivative. So first it says determine whether the mean value theorem can be applied to f on the closed interval. If the MVT can be, MVT standing for mean value theorem, can be applied, find all the values of C in the open interval a to b such that the derivative equals the average. Okay, so the first thing we need to do is we need to find the average slope. So basically we're using m equals y2 minus y1 over x2 minus x1, the slope equation. That's basically what this is. Okay, f of b minus f of a over b minus a. So they've given me this a and b. So I need to find f of a, which is f of 0, which is 0. And then I find f of b, which is f of 6. Okay, and you plug in 6. And 6 cubed is 216 times 2, which is 432. Okay, so we plug that into our equation, and we get 432 minus 0 over 6 minus 0, which is 432 over 6, which equals 432 divided by 6 is 72. Okay, so we know that the average slope is 72. Okay, so now what we're going to do is we're going to say, can we use the MVT? So next time I'm going to find the derivative, f prime of x, which is 6x squared. Now, before I'm going to even see if there is a place where it works, I need to find out, is it possible to use the MVT? Well, to do that, I'm first going to plug in f of 0, f prime at 0. F prime at 0 is 0. F prime at 6 equals, and you plug 6 in, so you get 6 times 6 squared, which is 36, which is 216. So this is going to tell me, is it possible? Is there a value? Well, yes, there's going to be, because the intermediate values theorem says I can't get from 0 to 216 without passing through 72. So there is a place where the slope is going to be 72. Okay, so now I got to find that place. So now what I'm going to do is I'm going to say, well, I need to know where this is equal to 72. So that's where we start. So we take 72, divide 6 on both sides. So we get x squared equals 12. And then we get x equals plus or minus the square root of 12. And the square root of 12 is approximately 3.464. Okay, now I can automatically throw out the negative one. It has to be the positive one. We can only use the positive one because my interval is from 0 to 6, and negative 3.464 is not in my interval. So my solution is that positive 12, or approximately 3.464. That is where my slope at a point, my derivative, is equal to the average slope. And you could plug it in. If you plug in, 3.464 squared times 6, you get approximately 72. You get 71.995, which is basically the same. So this is what the mean value theorem is about. Is it possible, and that's what we checked first right here. We said, okay, is it possible that there is a value? Well, yes. Since my slope values go from 0 to positive 216, there's no way, if this is continuous and smooth, that that value is not there. It has to be there. You can't get from 0 to 216 without going through 72. So then at that point, we found where in my function the slope itself was 72. So very similar to finding where we have horizontal tangents.